All right. Well, if nobody has any questions or concerns, I'm going to go ahead and introduce our speaker and we'll get started. So as I mentioned earlier, we're going to be talking about water regulation, compliance, and conservation in manufacturing. I'm excited to hear about this topic today. I don't think it's anything we've really touched on before, so excited to hear about water quality from a different perspective. Our speaker today is Bob Cole. He is the Sustainability and Environmental Project Manager with Dana Incorporated. He's been with Dana for 34 years now, so I would say a long career with Dana. He started out working at their Fort Wayne facility in 1987, and then in 2006, he became Dana's Regional Environmental Manager focused on regulatory compliance. And then from 2019 to present, he is serving in his current role, and he's focused on their global sustainability, data tracking, and operational improvement projects. So it sounds like you're doing a lot of the tracking of the environmental and sustainability indicators and things, and making sure that Dana's practices stay sustainable and continue to become more sustainable. So that's great. So without further ado, I'm going to hand it over to Bob, and we're going to hear about what Dana's doing on sustainability and water quality.
All right. Thank you, Melissa. Let's see. Did the presentation show up? All right. So as Melissa said, I've been with Dana for 34 years, and this is actually one of my favorite parts of the job, was working with water, especially with Fort Wayne, one of the largest manufacturing facilities. And that's where I kind of cut my teeth in environmental compliance and received my wastewater treatment license. A little bit about the Fort Wayne facility itself. It was founded back in 1945 as Salisbury Axle, and they added another large expansion in 1951. The plant currently just under 1 million square feet, just under 1,000 employees, supply customers, Jeep, Ford, GM, Nissan, and Toyota. And this facility doesn't assemble anything anymore. They pretty much machine components and send it to our assembly facilities, which the Toledo Jeep plant is one of those facilities. Quite a history for the facility. Just looking at the manpower, when it first started, around 500 employees, quickly went up to over 1,000 employees. And then when the aircraft gear plant was added, it jumped over 2,000. And it held there for quite a while. And in automotive, you always have up and downs with the industry. And you can see that we're currently, like I said, about 1,000 employees. These are the different components machined here at the facility. Most of these come in as forgings and castings, and then we machine them to specifications, and they are sent to our assembly facilities. The gears is probably the most complex, with all the cutting and grinding and heat treating and lapping that goes into that. That is quite an involved process for that. And at the bottom, you can see the gears that are built here and made into a sub-assembly that are sent to our assembly. On the right, something for a drive shaft, we do the same thing on the drive shaft side. We do make tubes here and then machine down the various yokes that go on the ends of the tubes to be sent to the assembly facilities. And what I wanted to cover today is looking at both the discharge and the water consumption. Facility has, again, quite a history. Started with industrial discharge permitting in 1979 or so to present through our lagoon system. And then we explained some of the modifications we had on that. Stormwater also came into play in 1990. And then we had to modify our permit slightly. And again, I'll talk about that in a little bit. The City of Fort Wayne discharge, we also have a permit through them for our sanitary and treated wastewater after October 2010. And then water consumption, at one point we still had well water, but the facility was designed to be fed with well water and city water to feed the operations. And one of the reasons we're talking about all the way from Fort Wayne is that we dump into or discharge into a small creek called Newhouse Ditch, just by Run Creek, to the St. Mary's River, to the Maumee River. So our discharge ends up all the way in Lake Erie. So it's been a part of our discharge permit, and it impacted us in 2008 because of the Great Lakes Initiative for discharging through the lake to Lake Erie. I want to talk a little bit about the history of the facility now, because it's really important to see back in the 1946, they were actually thinking about wastewater treatment at that point and how to better control and discharge our water. The facility, when it was first built, was on 94 acres of land, and it was considered just outside the Fort Wayne city limits. At that point in time, the city has certainly swallowed us up since then. But the north third of the property was 32 feet below the floor line of the facility. And there was a creek along the northern end of that property that was a little bit above the lowest part of the property. So that provided a natural flow for the waste treatment process. The facility was constructed with a series of both storm sewers, sanitary sewers, and soap lines to collect the various types of water being created within the facility. The storm sewer, of course, would be roof drains, parking lot drains, and non-contact cooling water. And that was sent directly out to the creek. We had sanitary lines that, of course, went to the city. And then a soap line, it was called a soap drain, that would collect industrial process waste, alkaline cleaners from washing operations, various oils, emulsified oils from machining, boiler blowdown, things like that, more of industrial process type waste. And the actual wastewater treatment process itself, you can see the diagram on the right where the facility was here, and then the water at about 150 gallon a minute would go to a settling pit to drop out any solids and help the oil separation, and go into a first detention basin, which would further enhance the oil separation so the oil could be removed. And from there, it would flow down into another settling area. And this was approximately 15 acres of area that the water would sit anywhere maybe up to 3 feet deep, about 25 days retention before it was discharged to the creek. So that was the first type of wastewater treatment system the facility had. The person, his title was a waste engineer, Charlie Griffith at the time, wrote a purification of waste and metalworking plant back in 1950. It was an internal Dana document. And I was lucky enough to find a copy of that when I was researching for this presentation. And they had done a study on looking at how the facility was impacting the discharge into the creek in 1950. And they found that the discharge actually showed a BOD, a biological oxygen demand reduction of 93%, suspended solids reduction of 83%, oil and grease reduction of 95%. So they were getting some pretty decent results, just letting the water naturally degrade through the second detention basin. And they're even working with the city of Fort Wayne sanitary treatment plant. They would help collect samples and conduct these analysis for the facility until the Dana plant was able to establish their own analytical lab on site. And they also looked at how we were impacting the creek. They took samples above and below the Dana discharge and discovered that it was actually an improvement in the creek dissolved oxygen. Really, pH, oil, grease didn't change, but we were starting to provide up to 75% of the water volume, especially during periods of dry weather. So it seemed to be the concept of using the lagoons to treat the manufacturing wastewater was successful. And this was something there wasn't much history on at the time, using this type of a process for the emulsified oil type waste. When the facility started growing, they added another division or another facility called aircraft beer, and it was a 415,000 square foot addition to the facility. So it was a very large addition. And this plant, just as the name sounds, they were going to manufacture various gears used in aircraft. And that would include gear cutting and machining processes, heat treating, carburizing, and also plating with its own wastewater treatment, which would end up going to the city off the plating treatment. And at the time, they were trying to decide, what can we do? Is the current waste system going to be able to handle the additional flow? Because they were going to combine all the sewers together into one flow from both facilities. They decided the lagoon wastewater should work for both of the facilities. It was similar type wastes from both facilities. So they decided to enhance the lagoons a little bit. And here's a picture I found of the 1951 construction. You can see on the left-hand side of the picture, this is the outline of the new facility being put in place. This was the original first retention pond. And this was the area that the water would flow down into. And they were constructing lagoons now to have a better controlled process of water. And this, they needed the fill dirt for the parking lot for the facility. So it was easy to construct the ponds, move the fill dirt over here to this area for the parking lot. So this was all part of the construction for the new facility. And then in the next piece of data I could find was in 1954. The wastewater treatment system now consists of 4 lagoons receiving up to 250 gallons per minute. So it increased the flow by quite a bit, from 150 up to 250 gallons per minute. And now you have structured lagoon systems where the first basin allows any free oil to rise and any solids to settle with a detention time of approximately 3 days. Then oil was skimmed from the surface of that lagoon. The second basin, and you can see over here on the right, we have the first basin and the second basin, very similar construction. The second basin would handle any residual that would flow through from the first basin. So it would also pull any remaining oils or any solids out of the water. And then the water would flow into the third basin. This basin would allow the dissolved oxygen levels to start increasing and would see some biological activity and the waste starting to break down. And then the fourth basin, which was the largest basin by far, was this whole section connected. And it was approximately 11 surface acres altogether and about 40 days of retention time. And then a concrete discharge was constructed over in the northeast corner of the lagoon area that would allow controlled discharge to the Newhouse ditch, the creek we were discharging into. And then the storm, or any of the storm sewer or non-contact water would flow and connect with the discharge coming from the lagoon system. And they saw an even better waste reduction with the increased 250 gallon a minute. Now they're seeing 99% oil reduction from what was being received into the first basin, now flowing out of the last basin. 99% reduction in suspended solids and almost a 98% reduction in the biological oxygen demand. So they're seeing very good results through the system. And this was just natural breakdown of the lagoon itself, or of the wastewater in the lagoons. Charlie even submitted a study at that time to a journal called Sewage and Industrial Waste. It was a 10-page study looking at the period of time when they constructed the lagoons and filled with data and what type of waste are being treated to our lagoon system. And they would also show results of the creek itself above and below our discharge again. So that was kind of neat to see that something like this was published back in 1954, describing the waste process and how it could, the waste could naturally degrade. Fast forward to 1960, you can see the plants getting a little bit larger. You can see the lagoon system better here, actually in process, where it's a flow through process, continual flow through from the facility out to the lagoon system, and then discharge over here into the new house ditch. And then the stormwater ditch ran along this side of the east side of the lagoon system. So now I'm going to jump all the way to 1974. There was a big data gap. There wasn't much really recorded between these times. And in 1974, the facility received their first NPDES discharge permit issued by the Indiana Stream Pollution Control Board. And it was a fairly simple permit, looking at the requirements, looking at the BOD, total suspended solids, phosphorus, and oil and grease. It was based on monthly testing. The flow rate was recorded and sent also. And at the time, there wasn't a true treatment process that we would think with equipment. This was all still based on using natural degradation of the wastewater through the lagoon system. But in 1976, the facility knew they were going to have to improve their treatment with chemicals starting to become more synthetic. They didn't break down quite as easy as they did in the previous years. So a reverse osmosis for phosphorus removal and ultrafiltration for the emulsified oil removal was added to the facility in 1976 to try and improve the treated water quality. And another improvement was in the third basin. Surface aerators were now added to increase the dissolved oxygen levels more. The original fourth basin was redesigned as 2 lagoons. So now we had a smaller lagoon that was at the final discharge. And this was done to try and increase the retention time to the lagoon system. And the facility would occasionally have issues with phosphorus. And since this was going to Lake Erie, phosphorus was a big issue. They had a limit of 1 part per million, and sometimes they'd just be over 1 part per million. So they're looking at trying to come up with a better way to treat the water. So a study was conducted in 1978 to review the wastewater operating process and investigate options. You know, is there something better that we can look at for the facility? The RO and ultrafiltration system was working okay, but it was very labor intensive. And with the facility 24-hour flow, they needed something that would work better for a full flow through process rather than the ultrafiltration. And another facility picture from 1981. This is when the facility was at its full under roof area, almost 1.5 million square feet. Now you can see up here the 5th basin had been created by itself. 4 East was still a fairly large portion of the ponds. The other lagoons were here. You can see the aerators in 3rd basin back in the corner. So as part of the 1978 study, of course, different types of facility treatments were looked at. And in 1983, a tank was added called an API, American Petroleum Institute, that would use coagulation flocculation as a flow-through process. And this tank could handle up to the 150 gallon per minute without an issue. Polymer and aluminum sulfate was part of the program for the coagulation flocculation chemical. And again, the API could operate 24 hours a day, much less labor intensive with this type system. A problem with the whole system, wastewater collection of the soap drain, however, was that we're still subject to untreated influent into the first basin during high flow or storm events. It would kind of overpower the drain system, and we would push some untreated water out, which at the time it wasn't a very big issue because the system could handle it. And the MPDS permit requirements pretty much stayed the same through this time period, and we weren't having too many issues. A little bit about the coagulation, flocculation. The pictures on the right show a jar test. The jar on the left is untreated wastewater. The jar on the right is the treated wastewater with the polymer and aluminum sulfate. And you can see the flock that's formed and the clear water between the flock. The flock itself, because it contains oil, in the lower picture will float to the surface of the water and can be skimmed off. And then the treated water would flow out to our lagoon system into the first basin. And then in 1987, to improve this even further, we added a dissolved air flotation unit to the existing coagulation flocculation. So now the API itself would only be used for free oil removal, and the chemicals would be added to the dissolved air flotation unit. And with extra air into it, it had a better mixing system, flash mix, and a paddle wheel section that greatly improved the quality of the water being treated. At this point, lagoons are no longer considered the primary treatment because we're pulling the oil off before they're getting to the lagoons through this treatment system. We also added aerators to the lagoons 4 east and 4 west to help improve dissolved oxygen and enhance the BOD removal even more. And in 1990, we made a few more changes. The lagoon system was further modified. We pulled out basins 1 and 2 and eliminated them altogether. The lagoons were cleaned out and backfilled, and we put it in their place a new we called it North Wastewater Treatment Building. And you can see the in-ground tanks, concrete tanks, and this is based almost on a city type sewer collection system where it was the primary treatment tanks. With these 40,000 gallon tanks, they have the skimmer scraper system. So we could collect the oil off the top, and also the heavy solids that would be on the bottom would scrape to the back side of these pits and could be removed from the system. And these tanks provided oil and solids removal much better than the lagoon system ever could have. And it also would equalize the wastewater strength. So we wouldn't get the slugs coming into the wastewater system with the coagulation flocculation. And then the tanks would also provide our extra capacity so we could contain stormwater events much easier. We would typically work out of 1 tank and keep the other 2 empty to help handle with high flow events or storm surges. And this is a more recent picture of the facility. This is our little wastewater treatment building here in the kind of the middle of the picture. And you can see the lagoons now are gone. First and second basin are gone from the system. And we would discharge all the way out to our 3rd basin now. And then the water would continue to flow through the lagoon system to the discharge point. So our MPDS permits have been pretty basic, all along without much issue. In 2006, we received a renewal, and they had quite major changes in the permit. We still had the BOD, suspended solids, pH, oil and grease, the total toxic organics, and those were no issue to meet. But now we had ammonia, metals, total residual chlorine, and toxicity testing. Those were all new requirements for us to look at with our lagoon system. So in the first year, we were primarily just collecting data against these new requirements in our permit. And then really into 2008, 2009, we really started having some challenges with our discharge, especially with the winter cold. You can see the pictures on the right, our lagoon system's frozen over. Aerators will still work, but the biological activity in the ponds would really fall off in the wintertime. And so the ammonia and the BOD natural breakdown would really slow down during the wintertime. And then on top of that, you can see on the bottom picture, we could get up to 1 to 200 geese and ducks sitting in our lagoon system during the winter, because we would have a little bit of open water. And the Franke Park Zoo isn't too far away. So we had a lot of activity coming over, and that would help even add to our loading, our BOD load, with all the ducks and geese releasing their waste into our water. We also had, in the summertime, algae would impact our total suspended solids testing. We had a new requirement with toxicity testing, which we had never had to run before. And this had two portions to it. One was a minnow test, which the minnows would be allowed to swim in our water that we would send into the laboratory for 7 days. And then they had to show that they didn't lose any weight during the process. And also the second part were water fleas or water daphnia. The test was designed to show that the water fleas could live in our water and provide offspring for a number of days. So the basic part of the test, the fleas had to survive and produce offspring, and those were compared to a baseline sample. And that test started causing us some issues. We couldn't understand. We had fish in our lagoon system. We had daphnia in our lagoon system, but we were having trouble passing this test to show that there was no effect to the daphnia. In 2009, we performed a toxicity study to determine why we're having trouble with this test, and found out the Fort Wayne city water we used as non-contact cooling water that was placed into our lagoon system was lethal within 24 hours to the water fleas. So now we understood that the process, our non-contact cooling water, the city drinking water that we were putting into our lagoons, would kill our daphnia and prevent it from passing the test. We discussed it with IDEM, and they said, well, if you want to continue discharging, you're going to have to figure out how you can treat and pass this test. One thing we did do was we were able to divert the water. Normally a non-contact would flow into the 5th basin, and we brought it back 1 basin prior to 4 East, and it actually helped. We were able to pass the test after that without much of an issue. But it was the testing and the requirements were getting harder and harder, especially with our lagoon system in the wintertime. It was starting to have some impact. So in 2010, we made a decision to change our discharge. We thought the lagoon system was not good for final polishing anymore. We're going to have to figure out a different way to discharge. So we discussed it with the city of Fort Wayne and decided to discharge our treated wastewater to the city rather than continue to use of the lagoons for final polishing. So in October 2010, after our permit was approved with the city of Fort Wayne, we started sending in combined sanitary and wastewater discharge to the city rather than our lagoon system. And because of that, we were able to change our lagoon MPDS permit and downgrade it away from an industrial type permit to a non-contact cooling stormwater permit. So that helped our discharge also through our lagoon system. So those were some major changes for us, a lot of plumbing changes we had to do. It gave us better parameters for our discharge and allowed the city to perform the final polishing for our wastewater. And right now with our current wastewater treatment, we're treating approximately 31,000 gallons per day of wastewater. And we treat and discharge to the city of Fort Wayne. We continue with our lagoon MPDS discharge for non-contact water and stormwater. And any new emulsified oils and cleaning solutions must be jar tested for wastewater treatment compatibility during the chemical approval process. This helps us identify if we're going to have any impact with our wastewater treatment system at all. So that's our wastewater treatment, what we've done with that for now. I'm going to change gears a little bit and talk quickly about our water conservation we've had. Fort Wayne, being a manufacturing facility, we've had fairly high water use historically. I did find a study, that 1978 wastewater study, also outlined how much water we were using. And we were using 1,200 gallons per minute in 1978 for our facility. 85% of that was non-contact cooling of equipment. The heat treat, big user of non-contact water. Our air compressors use a lot of non-contact. And a lot of hydraulic sumps and induction equipment also use that non-contact cooling. So this is once through cooling water that would flow out to our lagoon system. So jump forward again, 1990 to 1999. We've dropped our water consumption at this period through some design changes, but we're still running at about 1 million gallons per day of water consumption. And then our wastewater generation and treatment, we're still at about 150 gallons per day, so that didn't change much. And 2000 to 2009, continued process changes and water reduction opportunities. We're able to reduce our consumption a little bit more. Our ISO, we created an ISO 14001 objective identified to reduce water consumption 1% per year. So our water consumption in 2009 is now all the way down to 180,000 gallons per day. And I'll show you some projects that we did to get there. And our 2009 wastewater generation has fallen all the way down to 27,000 gallons per day. So we did a lot of focus on where we're using the water and how we could reduce our consumption of water. And right now, what we're working with, really a culture change, looking at our water use, trying to get the idea that, it's important not to just use this water wastefully. So we have facility equipment process changes occurred, continue to occur throughout this time period. Now we have facility water meters, incoming water from the city that we record daily, and that helps us identify any abnormal consumptions. We can see if a machine all of a sudden is using more than it should be, and we can approach maintenance about that. We also record the cost per day and communicate this to the facility staff. That hadn't been done. With the non-contact cooling water, it's in pipes. You really don't see it going anywhere. It goes through the machine, out to our lagoon system, and no one really sees that, how much is flowing at the time. So that's how, when we changed and started recording our cost per day, that helped visualize that a little more for the management team. New equipment and process changes are reviewed to identify potential water uses in the facility. Current equipment consuming non-contact cooling water reviewed for alternate cooling processes. We continue to do that. We have a new project right now to have a small chiller put in place to reduce our water even more. And we conduct workshops to help identify non-value consumption of water through our processes. Again, just get the idea with that culture change, let's identify where we're using the water and how we can reduce that if possible. So our 2019 water consumption, 148,000 gallons per day right now, and our wastewater being generated and treated is about 30,000 gallons per day. That really hasn't changed too much for us. That's holding about even in 21. One of the projects I wanted to talk about was the heat treat consumption. There's water jackets, cooling water jackets on our heat treat furnaces. And at one point we were pulling out 500 gallons per minute through these systems. And in 2001, we put a project in place to capture that water and run it through a cooling jacket and a heat exchanger instead of the once-through cooling water. And our water consumption dropped from 1 million gallon a day to 685,000 gallons per day. So that was a huge drop looking at that. And some of that water was actually going to wastewater treatment. So it cut about 60,000 gallons per day out of our wastewater treatment system also. Another project, and this took place in 2002 for air compressors. The air compressors we had at the time were also water cooled, and we hooked a cooling tower to those air compressors. And so going into 2003, our water consumption now reduced another approximately 300,000 gallons per day, and wastewater was down to 64,000 gallons per day. So we're seeing, as we're looking at different processes, identifying how we can change these water flows and water usages is really showing value to the facility. And then in 2014, this is probably our latest project we had. The air compressors we had were replaced with air-cooled air compressors. So we were not using that cooling tower anymore. We decided to revamp this and again look at heat treat. We were still using city water through the heat exchanger heat treat, and now we hooked the cooling tower itself to the backside of the heat exchangers. So that was a project that was completed. And then we also purchased a cooling tower for a new tube mill that came into the facility. So our water reduction consumption went from 231,000 gallons per day down to 137,000 gallons per day. And our wastewater treatment was brought down to about 26,000 gallons per day at the time. So that's my presentation. Hopefully I left a little time for some questions, if there are any.
Yeah, thank you, Bob. That was great. Yeah, I'm gonna go ahead and open the floor up. If anyone has any questions, I have a couple, but I'll certainly give other folks an opportunity to ask some questions first. I see two folks. I'll go to Dan Marsalek first. If Dan, you want to go ahead and ask your question?
Hi, Bob. As a fellow engineer, I appreciate the history behind all of this and what it takes to run equipment like that. My question for you is, was there ever any thought to reusing the water coming out of that fifth pond and instead of dumping it to creek, running it back through the facility to reduce your water expenses?
We did at one time, and the question was always, you know, we have algae and other contaminants, biological now in the pond water, and how we were going to have to treat that before we could push it back into the facility. And the temperature was also the other issue. The lagoons were approximately 5 feet deep. So in the summertime, we're pushing 80 degrees, 80 to 85 degree pond temperature. So really, we'd have to chill it or cool it off somehow before we could get it back into the facility. The other option we've always considered is trying to use it for irrigation around the facility, but we've never been able to set that one up either. So it was discussed, but we didn't think it was possible at the time.
Thank you.
All right, we've got a couple more questions that have come through via the chat box. So Mike Green wants to know, what cost savings did you see with the impressive water reductions?
With the cost savings here lately, I would say we're maybe in the $100,000 a year range in the last, since the 2014-2015 change. We really started recording the information with the cost. The cooling tower that we installed, I believe the cost of the tower itself was $200,000 for all the pipe work and the equipment. And we're able to pay that back in 2 years. So we're showing since that was put in end of 2014, we're showing a positive on that one quite a bit by now. So depending on, of course, your city cost, but we found also that if we could, the bigger impact was on our wastewater treatment. It was, we're up to about 3 cents per gallon through our wastewater treatment. The city cost 0.003 cents per gallon. So the city waters was much cheaper, but it still has an impact. If you're talking about a million gallons, it adds up fairly quickly. So there are some significant cost savings to be had in the just saving the city water. It's important to document that. We found with our workshops to be able to identify our water use and then also the cost of our water. To look back, and that's not only the actual cost, looking at the structure of the city invoicing on the taxes. If there's different fire costs added along with that. We did find even one instance where we had a 6-inch water main and 2 4-inch water mains, and we were paying more for the 6-inch water main by a couple $100 a month. And that was the water main where we're using our least amount of water through for the facility. So we're able to reduce that water main to a 4-inch. And just by doing that, we were able to save a good amount of money for the facility.
Great. Our next question is from Janet. She said, going forward, do you see reducing production days as a way to conserve more water if there are no other options?
It's right now we still have room to grow with the identifying our water use. One of the bad things about our facility, I guess, is the age of the facility and the structure and how the water flows into this facility. We're dealing with 100,000, we're with 1 million square foot. We sometimes have to run pipe quite a distance for a cooling tower or something like that, and that really adds cost to the program. So we're really staying away from the thought of reducing production at this point.
Okay, great. Audie wants to know, how often does any heavy metal sediments need to be removed from the lagoons?
Oh, we're pretty lucky on that. With the metals we have here, we've had no issues with any heavy metals to our lagoon system at all. We've tested, our water's been tested, and we've tested our sludge out of our lagoons, and that's not an issue for us.
All right. Well, I have a question, and if anyone else thinks of any, again, please put them in the chat box or raise your virtual hand, as Dan did. So I'm wondering, Bob, doing some of the water conservation measures at the facility, was that a hard thing to get buy-in for? Did those requests come from higher leadership? I guess I'm just wondering what was kind of the motivation behind doing some of that.
I think once we established an ISO 14001 program, it gave a better look at how we were impacting the environment. And one of the ways this facility had the high impact was the water use. It was one of the highest water users in Dana. So we wanted to definitely look at that and get a better understanding of how we could get that message out to the management of the facility. And one of the ways we're able to do that was look at the cost and start communicating the cost of our water use. That had not been done in the past. The management team weren't aware of what the cost of the water was usage for the facility. Could show in the summertime when we had the high non-contact water use that we could be using $1,000 a day worth of water. Thermostats just being wide open on machines and a lot of flow out to our lagoon system. So by using that data and presenting it in our ISO 14001 management reviews, we could really focus on look at this cost. And once we got associated with the cost, it was probably acted on much quicker, looking at what kind of cost savings we could have. And then we got the additional benefit of reducing our impact on the environment also.
Okay. And since you've mentioned it a number of times and it's kind of answered one of my questions I did have, can you please just explain a little bit what an ISO 14001 is, or what that program is?
It's a standardized management system, and it's really focused on how you're impacting the environment. You look at all the facility aspects, looking at emissions on the environmental side, of course, any type of emissions, air emissions, water, discharge, waste emissions, looking at how you are impacting and how you can reduce that impact on the environment. It could also be, greenhouse gas emissions with sustainability. That's a big issue right now. So that's a big impact. Even looking at how employees driving to the facility is impacting the environment. So it really gave you an opportunity to also standardize processes within the facility. So if you have a work instruction, you would need a work instruction for a specific process, like a waste handling process. Sure everyone was doing it the same way and wastes were being handled properly. And like I said, you could establish objectives and targets as part of the program also then, looking at how you could reduce your waste. So we really focused on water, waste, and energy as all key impacts on the environment. And this system was really designed if, say, I would leave the company, do you have a process in place someone else could just step into behind you, and you'd see a procedure and operating instructions on how to perform your tasks. So that's really helped us also identify key aspects for the facility.
Okay, great. Dan, your hand has been up. I thought maybe it said, do you have another question?
I have another question.
Okay.
So I took it down, put it back up again. My question is, the lagoons, you said, are about 8 foot above the top level of the creek. Has there ever been an event where you guys have flooded the lagoons or had issues with containment? And do you ever have to dredge those lagoons? And if so, is that sediment specially treated after it's been dredged?
The only time they were ever dredged, well, first of all, that was originally on the layout or the topography of the facility before they dug the structured lagoons, when it was above the creek line. The creek would actually flood, I guess, at one time into our lagoons when it had the first detention basin back in the early days of the facility. Once the lagoons were structured, we have not had any issues with overflowing the lagoon system itself. We have had times where there are dikes between the lagoons that we've overflowed between the dikes on a very heavy storm event between the last two lagoons. But we always have enough room to handle any flow coming into the facility for the discharge. We could definitely push up very easily to over 1 million gallons a day on the discharge during a storm event because of all the impervious area we're picking up from the facility. On the solids, when they had the first two lagoons, they did have a solids buildup because it was getting a lot of the grit from the machines, dirt from the machines. And when those were dug up back in the late 80s, those were professionally, we had a company come out, they went to the landfill, all the soil was tested and everything was approved as it went into the landfill. So we did have to check that as more of an industrial type waste for that. The third lagoon was also cleaned out and put back into service at the same time the first two lagoons were cleaned out and refilled. The other lagoons, we've never had an issue with. They have a lot of leaf and just probably organic matter buildup from them from over the years, but we've never tried to dredge those at this point.
Thank you.
All right. Are there any other questions? We have about 5 minutes left. All right, I have just one more.
Okay.
So in the 1960s, I believe it was the 1960s, Lake Erie had a phosphorus issue. We often hear that it was resolved. And then, you know, we've got some phosphorus issues we're dealing with now. But back in the 1960s, industrial discharges were responsible for the phosphorus. And then most facilities were able to clean up that discharge relatively quickly. I'm just curious, did Dana have to do any of that? Like, were they part of that cleanup at all? Or
I really didn't see much history of that look documentation. I know they were using aluminum sulfate to try and between the first basin and the second basin at some point. And I think that was to help break the emulsified oil. And that's another additive you can use for phosphorus removal is the aluminum sulfate. And so I'm guessing there was a lot of attention paid to phosphorus at the time because of all the issues. And that may have been why. But I didn't get to see any test results to see if there was an issue at the time or not.
Okay.
It was looked at, definitely. It was, the phosphorus levels always seems to have been in the permit.
Yeah.
Because of the Lake Erie connection, I'm sure.
Yeah. All right. Well, if there are no other questions, I want to thank Bob for his time today and for that great presentation. Bob, I am going to ask you if you could stop share your screen for a second so I can share one more slide with everyone before
Sure.
we sign off today. Thank you. And thanks again. I'm going to go ahead and share my screen. All righty. All right, well, that was great. Thanks again. And thanks everyone for attending today. Before we all sign off, I did want to let everyone know that our last luncheon of the year will be Thursday, November 18th, and the topic will be vibrant neighborhoods. So that'll be a good one, and we're excited to plan for that and hope to see all of you and more there for our next luncheon. If you have any further questions for Bob after the presentation, feel free to send me an email and I'll make sure Bob gets those questions. And also this will be recorded and posted on the Sustainability Commission's website if anyone wants to go back and reference it in the future. And I think that's it. So I, again, just want to thank everyone today for your time and attention, and Bob again for his expertise, and I hope everyone
Thanks for the
has a
opportunity. I enjoyed it.
Yeah, no, it was great. Thank you. Yeah, everyone have a good holiday weekend, and thanks again. Take care.
Thanks, Bob.
Bye.